Hello, in this video, I will show you how to quickly run a linear discriminant analysis using R. As you know, an LDA is to classify subjects into different groups based on the value of a set of continuous variables. So LDA is a supervised learning method. Okay, so it's very useful in, say, disease diagnosis, image classification, etc., etc. Okay. So let's first set a random seed using today's date, and then I'll create an artificial data set. So I will have three groups. Each group will have 50 data points, and here are the group means and group covariance matrix, assuming all three groups have the same covariance matrix for simplicity. And then we write a function generate group data in which we call the MVR norm function in the math library. Okay. And then we just generate three groups data. We put them together and then add a group variable indicating the group membership and assign column names for first 5 columns as variable 1 to 5. So here's what it looked like. All right, so do an LDA in R is very simple. We use the LDA function in the math library. So look at the syntax here. It's math colon LDA. So in this way, you don't have to use the library math, load the library first, and call it LDA. You can just directly access LDA function in the math library. And also group tier dot data equal to data. So this syntax group tier dot is a shortcut for you to tell R the group is the dependent variable, and then tier dot is a simple way to tell R that you're going to use all the rest of the variables in the data set. So this really is convenient when you have a large number of predictors. For example, if you have 10 variables, you don't have to type variable 1 plus variable 2 plus variable 3, etc. You can just say group tier dot. Okay. So let's run it. It's pretty quick. And we print it out. You can see it has the group means and the coefficient. Those are the coefficient for the linear combinations for the linear discriminant 1 and 2. So and for variable 1, 2, 3, 4, 5. And you got the trace there, and then you can see by default R treats the prior probabilities of groups as equal. So each group has a 1/3 probability. Okay, and you can change that prior probabilities if you have imbalanced data set. You have more subjects in one group compared to other groups. Then you can assign custom priors. For example, we can say 0.3, 0.4, and 0.3. And then you can run a quick check. All these prior probabilities should add up to 1. And so for this problem, it passed the test. And then you can fit an LDA model with the prior by calling that LDA function in the math library, but now you need to specify prior equal to custom priors. Okay. And if you do that, you can print it out. You can see now the prior probabilities are 0.3, 0.4, 0.3 as specified, and the group means and the coefficients are a little bit different. So it does impact the results. So you need to be careful with the prior probabilities. When you have a data set, usually you can choose the sample frequencies of the group membership in the data. Okay. All right. Once you have done the LDA, you can look at the outputs in different ways. For example, there are some built-in functions for plotting the LDA objects. So here's the biplot. You can see the group 1, group 2, group 3. They separate pretty well in this case. And we can also do a pairs. And this will give you the LD1 and LD2, and also the separation of the 3 groups. Okay. And you can do LDA histogram for each of the variables. You can in the 3 groups, so you can see they are separated. The group 2 of this variable 1 for group 2 is leaning the group 2 leaning toward to the right, so it's kind of larger in group 2. The variable 1 has larger means in group 2. Okay, or you can do with the group variable 2. It looks a little bit different, and now the group 1 has the larger means. Okay, and also you see the histogram and the density plot. So give you some idea about the data distribution. Okay, and when you do classification, popular performance index is the confusion matrix. So you can sorry, I need to generate the prediction first, and then print out the confusion matrix. This is a little bit out of order, but okay. So in this data set, we did a perfect job. Okay, 100% accuracy in the classification. But this is a made-up example. Okay, and you can also do more kind of detailed plotting. For example, you can use ggplot to plot the scores. Still, this is a biplot. You just do it by using your own code, R codes to do it. You can do density plots, look like that. And then I also want to show you the other 2 libraries I found which can do biplot, but they kind of requires you fit the LDA model using a little bit different syntax. So here I use the LDA in the math library, but then the data I use is data, the first 5 columns in the data set, and then the grouping variable, which is the dependent variable, is the 6th column. So I do that, and I need to use the function called the ggbiplot in the library of compls. The RStudio version I'm using is a bit old for this package, so I installed the package directly from GitHub. So I load it in, and then I use the ggbiplot. It looks like that. So this from the origin, you'll see 5, vectors pointed out, but unfortunately it's not labeled. We don't know which variables which. But you can see the 3 clusters of data points. So you can get a better biplot by using the R library called the ggord, and you use also you download it directly from GitHub. You load it up and you use this syntax. And this one is better because it labels the variables 1, 2, 3, 4, 5. So you can see the points, data data points are separated into 3 groups with different colors, and the vectors pointed to different cluster of data points, meaning these are more associated with these data points. Maybe they loaded more on this variable. Okay, and the angles between the variables may indicate some of the association between these data vectors. Okay? This is a better biplot. It also has the explain the variance for LD1 and LD2. Okay? So my vote goes to GGOR. All right, and this is really a quick tutorial for performing an LDA using R.